Consider a three-digit code ABC where each of A, B, and C is assigned one of the values 1, 2, 3, 4, or 5. Find the total number of possible codes, assuming that each value can be repeated, for example, 1 to 1 or 4, 4, 4. So that means we have 3 slots, and then there's like 5 options here, 5 options here, 5 options here, because there are 5 numbers. So it just becomes 5 cubed, or 1, 2, 5 for II, assuming that no value is repeated. Similarly, it's like 5, but then there's 4 choices and then 3 choices. So it comes 5 times 4 times 3, which equals to 20 times 3, 60. And then let P of x equal x cubed plus ax squared plus bx plus c, where each of a, b, and c is assigned one of the values 1, 2, 3, 4, or 5. Assume that no value is repeated. Consider the case where P of x has a factor of x squared plus 3x plus 2. Find an expression for b in terms of a. Well, the way I would do this is I would equate this into this times another factor, because it's a cubic and this is a squared. So x squared plus 3x plus 2 times x plus, I don't know, any letter, I don't know, m. And we can tell there's no like, I don't know, like, there's no like letter here either, because x cubed times x squared. So it's a 1, like the coefficient is a 1. So we just expand this value, this like these, it'll become x cubed plus 3x squared plus 2x plus x squared m plus 3xm plus 2m. And then we group in the values, so it equals x squared plus 3 plus m x squared plus 2 plus 3m x plus 2m. So, and we know, like the original equation, it's x cubed plus ax squared plus bx plus c. And the question is asking for b in terms of a, right? So our b equals to 2 plus 3m, and our a is equal to 3 plus m. So we just rearrange to make m the subject for the a. So we'll get m equals to a minus 3. And we can just substitute it here. So b equals to 2 plus 3a minus 9. And then b equals to 3a minus 7. Hence show that the only way to assign the values is a equals 4, b equals 5, and c equals to 2. So just to remind, the only possible values is 1, 2, 3, 4, or 5. So you could, like I would just substitute it all in and see which one actually work. So first, our c equals to 2m, right? So c equals to 2m, which equals to a minus 3 equals to 2a minus 6. So let's say a equals to 1, c equals to 2 minus 6 is minus 4, which is rejected because it's only from 1 to 5, not negative. Let's see, a equals to 2, c becomes 4 minus 6 minus 2, so also rejected. And then a equals to 3, c becomes 0 because 6 minus 6, which is not one of the values either, so also rejected. And then let's say a equals to 4, then c becomes 8 minus 6, so c becomes 2. And let's try b equals to 3a minus 7, so 12 minus 7, that is 5. Now we can also try a equals to 5, because we're trying to show there's only one possible solution. So a equals to 5, c equals to 10 minus 6, which is 4. But then b becomes 15 minus 7, which is 8, which is rejected. So the only solution is A equals to 4, B equals to 5, and C equals to 2. Express P of x as a product of linear factors. So that's just long division of these. So x squared plus 3x plus 2, x cubed plus ax squared plus bx plus c. So then times by x, so x cubed plus 3x squared plus 2x, and then all this minus comes. Oh, we already have our values for a, b, and c, so we can just substitute it in. So a is 4, so 4x squared. B equals to 5, so 5x. And then our c is 2, so plus 2. So then this becomes x squared, and then 5 minus 2 plus 3x plus 2. So then, yeah, just 1. So p of x equals to x plus 1. And then this x squared plus 3x plus 2, I guess doing a long way, x plus 2x plus x plus 2, and then x plus 2 plus 1, x plus 2, x plus 1, and x plus 2. So our p of x is x plus 1, and then x plus 2. And then hence or otherwise sketch the graph of y equals p of x, clearly showing the coordinates of any intercepts with the axis. So we have our roots here because these are the factors, right? So our roots is minus 1 and minus 2. So minus 2 and minus 1. And for our y-intercept, we just equate x equals to 0. So yeah, so y equals to c, which is 2. So intersects at 2. And because it's a repeated root, x plus 1, that means it'll have this kind of shape. It'll touch it again and then go. Only here will it go from like positive to negative. Here it'll just go back up again. And then that's our answer.